Thank you to the SMU administration for allowing this event and this discussion to happen. Thanks to the hackers for their attempts to shut down this conversation. We regard that type of activity as a compliment. There's a famous Darwinian philosopher named Daniel Dennett who's written a book called Darwin's Dangerous Idea. Apparently the critique of Darwinism is equally dangerous. So what we're going to do tonight is to amplify some of the key arguments that you were exposed to, especially in the last quarter or so of the film. In fact, we're going to present two of the arguments that you heard in the film and two additional arguments, but these will be arguments in critique of modern evolutionary biology, modern neo-Darwinian theory. In particular, we are going to critique in a little more detail than you heard in the film the idea that the mechanism of mutation and natural selection has the creative power that has long been associated with it, power sufficient to produce fundamentally new forms of life. And we have tonight, in addition to me, 4 scientists, all of whom made at least cameo appearances in the film, who are specialists in different subdisciplines of biology. And they will each share some of the research that they have been doing and or research which has been going on in their respective subdiscipline of biology, which bears on this question of the efficacy, the creative power, the alleged creative power of mutation and selection. We think that modern neo-Darwinian theory is at a place of complete impasse, that it has failed, that it is failing dramatically, and we are going to present some arguments tonight that we think have an unparalleled analytical and mathematical rigor that can demonstrate the inadequacy of the Darwinian mechanism of mutation and selection. My role tonight will be a little different. Think of me as not so much a moderator, but as your scientific tour guide and translator. Each of these gentlemen have expertise in some very specialized areas of biology. And so I will introduce each one of the 4 talks that are to follow. And I will reserve to myself the prerogative of asking follow-up questions from each of them to clarify points if necessary and to summarize both before and after to help folks who may not have the same level of expertise in their particular areas follow everything. Okay? I think you will find each one of these guys, though, to be terrific communicators, and they have really compelling scientific information to offer tonight. In fact, scientific arguments based on cutting-edge evidence. But before we get into the 4 talks, let me provide a few introductory concepts and clarifications to as Darwinian theory, or more particularly modern neo-Darwinism, the current evolutionary orthodoxy. There's a difference between the observation. That is a misspelled word. That's not a good start. When we talk about evolution, we can mean 3 different things. The first is simply
the mutation.
It was a mutation. And it did not enhance the function of that. When we talk about evolution, can we pull it back together? Okay, when we talk about evolution, we typically use the word in 3 distinct ways. The first is just simply the observation that living organisms have changed over time. You move up the stratigraphic column of the column of sediments, you find that life a very long time ago was different than it is today. That's one sense of the idea of change over time. Another idea of change, now that's not the theory of evolution, that's just an observation. But another common descent or common ancestry. This was represented by Darwin with his picture, his tree of life picture of the history of life. On the vertical axis, the tree of life represents time going forward. On the horizontal axis, what is being represented is change in form. And the idea is that as you move forward in time, the very simplest organism or organisms that were at the very beginning of the history of life gradually morph into more and more complex forms until finally when you get to the branches at the top of the tree, you have all the forms of life that we see today. but they all are related by common ancestry back to that original simple form, one or very few simple forms, as Darwin put it. So that's the idea, not just of change, but of continuous change, of gradual and continuous change, a kind of morphing. Now, the third meaning of evolution doesn't refer just to change, it's actually referring to the cause of change, or to the mechanism by which change has occurred. And this is one of the distinctives of Darwinian theory, the idea that the mechanism of natural selection acting on random variation, or we would now say today in modern neo-Darwinian theory, random mutations, natural selection acting on random mutations, is the cause or mechanism for all the change that has occurred in the history of life. And so when we talk about not just the observation of evolution or change, but the theory of evolutionary change, we're talking about mechanisms such as mutation and natural selection that are alleged to have the power to produce all the forms of life that we see today. What we want to address tonight is the question of whether or not the principal neo-Darwinian mechanism of mutation and selection is sufficient to produce the forms of life that we see. In particular, we've used the example in the film of the Cambrian explosion. And so, in addition, let me introduce one other introductory concept, just a few words about why the Cambrian explosion is important. The Cambrian explosion is important because it is one of many, but perhaps one of the most dramatic examples of the origin of new form in the history of life. And when we talk about the origin of new form, we're also talking about, as the film made clear, the origin of information. I used to ask my college students, if you want to build a new animal, if you want to give your computer a new function, what do you have to give it? And being techies, they would all say, code, information. Well, the same thing is true if we're talking about living forms. We want to build a new form of life, we have to provide information. And as the film made clear, some of that information is embedded in DNA, and some of it resides in other places in the biological hierarchy. Now, that raises a critical question. When we talk about the Cambrian explosion, for example, or other examples of the sudden appearance of form in the history of life, we're not just raising a problem for Darwinian theory with respect to the fossil record. The problem is not just that there are gaps in the fossil records. What we want to focus on tonight, in fact, is a different problem, and that is, in a sense, you can think of it as an engineering problem. How do you build those fundamentally new forms of life, relying only on mutation and natural selection and other similarly undirected mechanisms? Can neo-Darwinism or any other theory of undirected evolutionary development explain how you build those new forms? Can it account for the new information that's necessary to build those new forms? So it's not just a matter of, for example, the Cambrian explosion, you have all these new forms of life that come into the fossil record at a particular point in time, but it's also, and the absence of underlying precursors, but it's also the engineering question. How do you build those new forms of life? Now, one tiny bit of clarification, we've had some questions raised about this. The Cambrian explosion is dated variously by different experts. The duration of it is dated variously. Dr. Sternberg and I were in a debate back in November with a geologist who claimed that the Cambrian explosion took 80 million years. But when we looked closely at his book, he acknowledged that there were a series of explosions, and while all he had done is group them all, put his little brackets around several explosions, and indeed that took 80 million years. But the key question is not how long. The key question is not so much the time of the various pulses of diversification, or the various radiations, as they're called. It's the origin of what's called anatomical or evolutionary novelty. And to get a sense of just how difficult that problem is in a temporal sense, let me just zero in on one aspect. We were talking in the film about the trilobite and its lens-focusing compound eyes. Trilobites first arrived in the Cambrian in formation in southern China, the Mao Shashan Formation, in and around a place in southern China called the Chengjiang. And they arrived in a sequence of sedimentary rock that has been dated by Samuel Goering, one of the leading geochronologists at MIT, to encompass between 3 and 6 million years of geological history. So it's true that there are additional pulses of new animals coming online that were in the Cambrian era. But the real question is, again, getting back to that engineering question, how do you build something as complex as a trilobite, or the dozen or so other representatives of new phyla that arose in that seam of rock within that 3 to 6 million year period? Now you'll see as we present some of this information tonight that even if we concede 20 to 25 million years, or 80 million years, or 100 million years for the Cambrian, it's still, as they say in Texas, not going to get her done. The mechanism does not have the creative power to do that, and we're going to show that tonight mathematically. But I want to just clarify this because we've had questions about how we have dated the Cambrian explosion. And again, the question is the question of the origin of evolutionary novelty. And that can be, we can zero in on that pretty tightly and say, you got to build a trilobite and a lens-focusing eye and those other interesting features of a trilobite within 3 to 6 million. Okay? Now, what we're going to do next is bring up Richard Sternberg. And he's going to present one of 4 critiques of the creative power of natural selection. We call this critique the population genetics critique. And what population genetics, for those of you who may not have taken an evolutionary biology class, is the mathematical expression of neo-Darwinian theory. There are equations of population genetics that tell how much evolutionary change can occur in a given amount of time, based on some key factors. Based on mutation rate, for example, it's one of the factors. Based on generation time, how long are the generations of a given organism, and how large are the population sizes. If you know those 3 factors, and you know the equations of population genetics, you can get a pretty good idea of how much evolutionary change can be expected within a given window of time. And what Dr. Sternberg is going to do is apply those equations of population genetics, not to the Cambrian explosion, which is in a sense the worst case scenario for neo-Darwin genetics, to establish this. In a sense, what that means is he's going to use neo-Darwinism to show that neo-Darwinism is inadequate. And I'll hand it over to him. Good evening, everyone. Can you hear me okay? Yes. All right, now let's see if I can figure this out. I have chosen what is called, was called in 2001, Darwin's poster child. That is the best case scenario for the gradual transformation of one type of organism into another, a supreme instance, if you will, of the engineering problem that Dr. Meyer just mentioned. Now, what you see here, if I can get the pointer to work. Anyway, what you see here is a textbook scenario of a nice gradual gradation from an initial wolf-like or cow-like hippopotamus-like ancestor. The actual ancestry of cetaceans is in question, but you start out with indeed a terrestrial mammal, and you end up with a fully aquatic quail in a period that is only 9 million years. And this is remarkable because the anatomical changes that are involved to go from a deerish mammal-like ancestor to a fully whale are indeed staggering. Now, we must keep a distinction in mind, 2 different categories. On the one hand, we have a pattern that is indeed supported by the fossil record. That is, you can analyze different fossil forms. Some of them are terrestrial. Some of them have an intermediate aquatic-like appearance, or they were amphibious. Others are indeed fully aquatic. That is, they were living 100% of the time, completing their life cycle in an aquatic environment. And so this pattern is not something that I would dispute and few would dispute. However, the causal explanation for this pattern is a different matter. What the causal explanation does is it says, yes, I've got this pattern, and what I want to do is I want to present a theory that explains it to some degree of satisfaction. And if you are a Darwinian, it is that you had relatively high mutation rates, you had natural selection come into play, and what you get incremental genetic change over time, and this is manifested by going from some terrestrial mammal to a fully aquatic mammal. Now, this textbook example aside, what we find is that the window of time, as I just mentioned, for this transition to take place is extremely rapid.